let's see if we can apply what we know about linear equations. One common task in applied mathematics is to solve a given equation and two or more variables for one of the variables. Solving for a variable means to transform the equation into an equivalent one in which the specific variable is isolated on one side of the equation. We accomplish this by the same methods we have used in previous lessons. Solve the following equations for the specified variable. All of the equations are formulas that arise in various applications, and they are linear in the specified variable. Okay, so let's have a look at A. We have P equals 2L plus 2W, and we want to solve this for W. Well, to do that, we need to move this 2L term to the left-hand side. So we're going to subtract 2L from both sides. 2L minus 2L is 0. We end up with P minus 2L equals 2W. Well, since this is 2 times W, to get rid of the 2, we divide by 2, because that's the opposite of multiply by 2. Whatever you do to one side, you have to do to the other side. 2 divided by 2 is 1, so we have W equals P minus 2L all over 2. Keep in mind, you cannot reduce those 2's because you have 2 terms here. The only way you would have been able to reduce this 2 is if there had been a 2 here you could reduce with it. Okay, so let's have a look at B. A equals P times 1 plus R over N all to the NT. We want to solve this one for P. This is P times all this stuff. Well, that means we just need to divide by all this stuff on both sides to get rid of it. So let's see what that looks like. Remember, whatever you do to one side, you have to do to the other side. Okay, that makes this entire thing reduce to 1. And we end up with P equals A over 1 plus R over N all to the NT. You have now solved this for P. My pen's not working very well today. Sorry about that. Okay, I'm going to go over here in this extra area that we have and work C. We have S equals 2 pi R squared. I hope I can squeeze this in. Plus 2 pi RH. Maybe you can still see that in the video. I hope so. We want to solve this one for H. So the first thing we need to do is take this entire term and move it to the other side. So we're going to subtract it from both sides. Since I don't have a lot of room, let me just write out what that becomes. S minus, because we move this over, we subtract it. 2 pi R squared, sorry, that's supposed to be an equals. There we go. Equals 2 pi RH. Now we still want to get the H by itself, so we need to divide both sides by 2 pi R. The 2 is reduced to 1, the pi is reduced to 1, and the R is reduced to 1. So you're just left with H is equal to S minus 2 pi R squared all over 2 pi R. Okay, let's see what we have on the next page. The distance from Shreveport, Louisiana to Austin, Texas by one route is 379 miles. If Matt made the trip in 6.5 hours, what was his average speed? Well, you know speed, or the rate, we'll just say speed in this case, is equal to, well, speed is in miles per hour, right? So distance divided by time, miles per hour. So he went 379 miles in 6.5 hours. So his speed would be equal to 379 miles divided by 6.5 hours. Well, let's divide that and see what we get. 379 divided by 6.5 is approximately 58.3. So since it didn't tell us what to round to or even to leave it as a fraction, we'll just round it to one place. So 58.3 miles per hour. You can also put mph in a case like this. So that was his average speed. By the way, for future reference, distance equals rate times time is a very, very important formula. And that's one that we used here, except it was solved for rate or speed. Tracy invested $1,200 in a risky high-tech stock on January 1st. On July 1st, her stock is worth $1,440. She knows that her investment is very volatile and that it does not earn interest at a constant rate, but she wants to determine her annual rate of return at this point in the year. What effective annual rate of return has she earned so far? Okay, so for this problem, we're going to use a very simple interest formula called I equals PRT. Interest equals principal times rate times time. Well, she earned interest. This is what her stock is worth now. This is what she paid for it. So she actually earned $240 in interest. So that would be the I. The principal is what she started with, which is $1,200. We don't know the rate. And we know that the time is from January 1st to July 1st. That's 6 months. So 1/2 of a year. Remember, in this formula, time is always in years. So this is the same thing as 240 equals, well, 1,200 times 1/2 will be 600 R. Now we needed to solve this for R, so we divide both sides by 600. This reduces to 1, so R will be approximately, oh, it's not approximate, it's exact. It is 0.4. So her effective annual rate of return is 40%, or 0.4, depending on how the problem wants you to leave it.